Hello. Today we're going to talk about relativity. And you, my friend, who doesn't know anything about physics, are going to get taught some. So we're going to assume that you're my friend. But more importantly, we're going to assume that you believe me when I tell you that light in two different reference frames, or really in any reference frames, is going at the same speed and is observed as such. So here we have reference frame 1 and reference frame 2. And from the perspective of both reference frames, this light has a speed of c. And now this is the case in every reference frame. Now, let's talk about clocks. So, here we have two clocks. These clocks are synchronized, meaning they are set to the same time, 8:31. Now, these clocks are in the same reference frame, and they are synchronized. And if this dude, we're going to call him Jimmy. Here's Jimmy. If Jimmy looks with his little scary eyeballs at both of these clocks, he sees they're at the same time. Now let's change it up. Here we have a box. A box that isn't actually a box, it's a rocket ship. And now we have these same two clocks. They are still set to the same time, 8:31. But they're in the rocket ship now. We're going to put a guy in here. This guy, he's Bob. That's Bob. So Bob in the rocket ship. Jimmy, who actually has a mustache that you didn't see before, is on the ground. So, right now, the spaceship isn't moving. They're in the same reference frame. Jimmy, if he looks at Bob and his clocks, he'll see the clocks are the same time. They're set synchronously to the same time. But rocket ships are not meant to float. They are meant to fly. So we're going to start moving with a speed of v. And now things are going to change. Bob is in the reference frame that's moving. Bob is moving with the same speed as these two clocks, and so to Bob, these clocks will be at the same time. They are still set same. Jimmy's going to see it a little bit differently. Now, let's suppose Jimmy's going to see these clocks at different times. And now I'm going to explain to you why. So suppose Bob has a switch in his hand that sets off these two lights on both sides of the rocket. And these lights go off at the same time, right? Now, to Bob, according to Bob, the light is going to strike him in the eye simultaneously at the same time. He's right in the middle of the light. The light is going to hit him at the same time from both sides and travel the same distance to get to him. From Jimmy's perspective, it's going to be a little bit different. Jimmy, we still got to put Jimmy's little face down here because he's looking. Jimmy with his face and his mustache. So now Jimmy, there's Bob. Jimmy's going to see it a little bit differently, right? Because the light's going to go off. And according to Jimmy, it's not actually going to hit him simultaneously. The light is not simultaneous. So to Jimmy, Bob, first of all, is going to be over here. And this light is going to hit him like this and like this. And as you can tell, Jimmy is going to see the light from the right side hits Bob from a shorter distance than the light from the left. Therefore, the light from the right is going to hit Bob quicker than the right on the left because, well, it has a shorter distance to travel, according to Jimmy. Now, the reason this is that Jimmy needs to still see this light moving at the speed of light, which is c. In all reference frames, c is supreme. So, Jimmy still sees the light moving at the speed of c, but to account for Jimmy and Bob and the rocket being in different reference frames, something else has to be messed up in order for Jimmy to still see the speed of light as c. And what happens is the simultaneity within that reference frame is not actually simultaneous for Jimmy. Jimmy views it as non-simultaneous. So therefore, this clock here on the left, this is the clock on the right, so it's not the clock on the left. But these two clocks actually won't be at simultaneous times because of the same reasons why the light hits Bob at different times, according to Jimmy. Because the speed of light needs to stay constant. So even if there wasn't light flashing in here, these clocks would still have different times, according to Jimmy, because the clocks, while moving simultaneously according to Bob, won't be, according to Jimmy, due to the same principle. The light is just here to make it easier to visualize. And so what did we learn? Well, we learned that the speed of c is supreme. Well, actually, you believed me that it's supreme before I started talking about this. So we know that. We also know that relativity messes up simultaneity. And I don't think that's spelled correctly. But you get the gist. And yeah. So hopefully now you know why those clocks, according to Jimmy, will not be set at the same time. Thank you.